Mandu of class 3 is going to demonstrate the experiment before you. Things needed: a burning candle, a soup plate, colored water and the glass. First, I will light the candle and put a glass over it. Now we see that candle has burned out and the water is coming in because candle needs oxygen to burn, so air outside the glass pushes the water in, so the water rises. Thank you.
Hello, today I, Abhisha of Kendriya Vidyalaya Kathmandu, stand before you to perform my experiment. Okay, the name of my experiment is who can drink water faster. I've taken two equal sized glasses and I've put two straws of equal size in both the glasses, and as you can see that I've made a small cut in one of the straws. So now I would like to suck water from this straw. As you can see that I'm able to suck water from this straw. Now I'll be sucking water from this straw, the one with the cut. You can see that I'm not being able to suck water from this straw. The main principle behind this is that the straw in which I have not made a cut, there's a vacuum between the top of water and top of straw. But the one in which I have made a cut, there's no vacuum as the air inside the straw is in direct contact with the atmospheric pressure. So, therefore, we are able to suck water from, faster from this straw. Thank you.
Hi, I am Ankit Verma from 11 Science, KV Kathmandu. I am here to demonstrate an experiment with this glass tube. We use these glass tubes in our chemistry labs. We use this to hold the water inside. How does it work? We generally go to that topic. We say that the air pressure inside the glass column and outside. There is a difference between air pressure. Air pressure inside the glass column is lesser than the outside, so that it is held, the water is held inside the glass column. When we open this, the water drops down. This is because the air pressure inside the glass and outside, it becomes equal and drops. Thank you.
Hi, I, Anmol Gandhi of class 9 from Kendriya Vidyalaya Kathmandu, stand before you to present an experiment on atmospheric pressure. The materials required for this experiment are a glass tumbler and a bucket of water. Firstly, fill the glass with water. Position the glass in the bucket in such a way that the mouth of the glass is just inside the water. We will observe that the water from the glass does not go down to the bucket. Now lift the glass a little in such a way that the mouth of the glass is just above the water. We will observe that the water gushes down to the bucket. Atmospheric pressure acts on the water in the bucket. This holds the water up in the glass. Thank you.
Good morning, I am Antika Malik of class 5, Kendriya Vidyalaya Kathmandu. I am going to show you an experiment on air pressure. Now see what happens. Here we have made a hose onto a plastic bottle. We see that the water coming out from the hose comes out with a lesser force as compared to the water coming out from the bottom hose. This because the water coming out from the bottom hose faces more pressure. Thank you.
Good morning. Today I, Jasmandeep Singh of class 10th, Kendriya Vidyalaya Kathmandu is here to demonstrate before you a very interesting science experiment. In this, we would require 3 saucers, identical saucers, 6 candles and 3 identical beakers. Now first, I would pour some water around the candles. Then, I'll keep the beakers on the candle. Now we can see the water inside the beaker is raised. It is because to reach the equilibrium outside the beaker, the water rises up. Thank you.
Good morning. Today I, Saurabh Agrawal of class 7 from Kendriya Vidyalaya Kathmandu is stand before you to demonstrate a experiment before you on air. First of all, we took this handkerchief and put this in the beaker. We took this and very slowly and calmly put this on this. And if we see that the handkerchief is not wet at all, this happened because the air was filled in the beaker already, and the air didn't allow the water to touch the handkerchief. So that's all. Thank you.
Good morning. Today I, Shubham of class 6 of Kendriya Vidyalaya Kathmandu is going to present an experiment before you based on atmospheric pressure. I require a bottle, a cap full of holes, a bowl and some colored water. Firstly, I will pour the colored water inside the bottle and I will close the lid. Oh, the water is not coming. I have filled water in and there are holes in the cap. Why is it not coming? Let me request the water to come. Water, please come. Oh, the water is coming. Wow, magic. Now let me stop the water. Water, stop. Oh, it stopped. Water, please come. It's magic. It's amazing. Wow, water stop. Wow, it's really amazing. Do you know the reason behind it? It's just a small hole at the bottom of the bottle. When the hole is closed, the atmospheric pressure doesn't allow the water to come out. But when the hole is open, the atmospheric pressure comes in and pushes the water down, and the water comes down. Thank you.
Good afternoon. Today, I, Shubhismita, stand before you to show you an experiment that is, air has weight. Materials required: 2 stands, 2 straws, 2 balloons, some threads, and 1 needle. Methods: take 2 stands and a straw of 15 cm. Paste them with a sellotape properly. Take another straw of 30 cm. Mark our center, that is 15 centimeter, and tie it up with the 15 centimeter straw vertically as shown over here. Take 2 balloons and inflate it. Tie it up properly on the 2 ends of 30 centimeter straw shown over here. Take a needle and fringe one side of the balloon like this. We can see that one side balloon filled with air goes down. This proves that air has weight. Thank you.
Today I, Yashasvi Lama of class 6 from Kendra Vidyalaya Kathmandu is going to show you an experiment called air pressure. For this experiment we need a glass, some water and a plate. First, take the glass, fill 1/4 of it with water and cover it with the plate. Hold the glass upside down and you will notice that the plate does not fall. This shows that the air pressure outside the glass is more than the air pressure inside the glass. Hence, the water does not fall. Thank you.
Hello, I am Abhishek of Kendra Vidyalaya Kathmandu, 11th Science. Today I am going to perform a simple science experiment before you. For that, we need a transparent funnel and a table tennis ball. Now, we put the ball inside the funnel and now we blow from the bottom of the funnel. Let's see what happens. As we saw, the ball rotates in its position and doesn't change its place. The principle behind this experiment is the Bernoulli principle. When the air blows, the pressure inside the air is greater than the velocity exerted by it. Thank you.
Good morning. Today I, Medha Upadhyaya of class 12 Science of Kendra Vidyalaya Kathmandu stand before you to demonstrate an experiment based on Bernoulli's principle. It goes like this. The air from the blower holds the ball in air. The ball is pushed upwards till the upward force equals the force of gravity. The ball stays at a highest point because the fast moving air creates a low pressure and the surrounding higher pressure air forces the ball to stay in the air. Thank you.
Hello everyone, today I, Shan Kafle of class 12 will be demonstrating a small experiment before you. Well, the name of the experiment is How Aircraft Flies. Normally we have seen many aircraft fly in the air. Now there is a principle behind this. You see this paper over here. Now I'll blow air in this paper and let's see what happens. See this again. Now we can see that the paper, it comes out up over like this. It doesn't go down. We expect that when you apply pressure, the paper must be going down, but it doesn't happen. Now there is pressure being applied from our mouth. Bernoulli's principle states that when a fluid flows, the pressure inside the fluid is greater than the velocity exerted. When you are blowing the air over here, there is a pressure below, that is the atmospheric pressure, and the pressure from our mouth, the vapor pressure that comes from our mouth. As a result, there is an imbalance between two pressures, and due to this imbalance, the atmospheric pressure below pushes this paper upwards, and this is how aircraft fly. There is a small demonstration from the wings. This is the wing of the aircraft. A typical aircraft has this kind of wing. This is also known as the airfoil shape. You can see it's curved from above and straight and plain from below. Now, when the aircraft moves from the runway, the air acts in two places. One, the curved path, one, the straight path. There are two pressures being created. One, the pressure below, that is the atmospheric pressure, and the pressure above. Now, when the air passes at the two places, one above and below, it has to cover a larger distance the above side. You can see it from here, there is a larger distance in the above side and shorter distance here. As a result of this, an imbalance is created below and above, and the atmospheric pressure thus created pushes the aircraft upwards. Now there are systems like flaps and all which covers this pressure, and as a result the aircraft flies. Thank you.
Hi, I am Astosha of class 12 science. Today I am going to demonstrate your experiment. This is U-shaped paper balancer. Now how to make it? First we require 2 coins, a carbon paper, toothpick, a sellotape and ruler and a scissor. Now let's see what happens when I try to balance on this stand. Firstly it would topple down. Now let's see when I make it low, this toothpick, what happens now. Now it is balancing. The principle is when the center of mass is low, it would balance, and when the center of mass is high, it wouldn't balance. This is my experiment. Similar is here. This is also balancing because its center of mass is low. Thank you.
Good afternoon. I am Manasa Joshi of Kendriya Vidyalaya Kathmandu. I am going to perform a simple experiment on center of gravity with the help of a Coke can. Now, as you can see, the Coke can is empty. In its empty state, it cannot be tilted because the center of gravity is over here. But when we add some water to it, the center of gravity changes over here, making it possible for it to balance. Now, as you can see, without water, it's unable to get balance. But when we add some water, about 1/3 of the size of the can, now when I added some water to it, the Coke can will get balanced. Now this is because the center of gravity has changed over here, right above the edge of the can. Even water has a very big role to play in this, as it levels itself with the edge of the can, helping it to get balanced. Thank you.
Good afternoon. Today I, Priyanka Sharma of Kendriya Vidyalaya Kathmandu, class 12 science, am going to show you an experiment on center of gravity. The name of my experiment is balancing forks, and for this I will require 2 forks, a coin and a glass. First, if we try to balance the fork on the rim of the glass, we will not be able to balance it. But if we intersect it by inserting a coin between them and place it on the rim of the glass, we will be able to balance it on the rim of the glass. The whole weight of the forks appears to be on the coin, but it does not fall. The reason is because the heavy handles of the fork curve inwards towards the glass, which shifts the center of gravity to a point directly beneath the coin, and this structure acquires the state of stable equilibrium. Thank you.
Good morning. Today I, Safali Agrawal of class 11 science of Kendriya Vidyalaya Kathmandu is going to show you an experiment on how we can balance a toothpick on the glass rim, which is the pivot point. You can see that I have balanced the toothpick in the rim of the glass. Now let's see what happens after burning the toothpick. That after even burning the toothpick, it is still able to stand on one point. This is due to the pivot point is lying on the vertical line of the center of gravity, and hence the toothpick is able to balance and is not falling down. Thank you.
Good morning. Today I, Upadhyaya of class 6 is going to show you an experiment on electricity. In this experiment, we need a watch, a metallic scale and a glue stick. I'll test these things with my tester. I'll use my wires on the material. The bulb is not glued. That means the material is a insulator. Now put the wires on this metallic part of the watch. The bulb is glowing. That means it is a conductor. Now I'll test with my geometry box scale. The bulb is glowing. That means it is a conductor. Now with my glue stick. The bulb is not glowing. That means it is an insulator. We conclude that the things which conduct electricity are known as conductors and things which do not conduct electricity are known as insulators. Thank you.
Good morning one and all. I, Priyamani Jha of class 12, Kendra Vidyalaya Kathmandu, stand before you to demonstrate an experiment based on the fact that pure water is an insulator while the salt water is a good conductor of electricity. For the experiment, the materials required are bulb, 6-volt battery, 3 pieces of wire each of 1 foot long length and 2 beakers with both having distilled water and salt. So first we'll connect this circuit and then we'll dip the ends of the wire in pure water. As we can see, the bulb doesn't light, so now we'll carry out the same with salt water. So we'll put some salt in it. Now we'll take the wire and put it in the salt containing beaker. Now as we can see that the bulb lights up. This shows that salt water is a good conductor of electricity while the pure water is not. Thank you.
Good morning. I, Sushant of class 5, KV Kathmandu, am going to show you an experiment on static electricity. First, blow up a balloon like this and rub it against your hair. And as you can see, my hair stands up. When electrons pass from my hair to the balloon, it attracts my hair. So my hair stands. Thank you.
Good afternoon. I, Kishan Singh of Kendra Vidyalaya Kathmandu, am going to present a simple demonstration of energy in physics. Here I will be requiring 2 marbles of different masses. When I place 2 marbles at equal heights and allow them to freely fall in an inclined plane, you will notice that it slowly stops at the same point. Initially the ball will be having some potential energy, but as it rolls down, the potential energy, mgh, will be getting converted to kinetic energy, which is half mv square. Thank you.
Good morning, my name is Angela Jetty and I am going to show you an experiment based on the topic centrifugal force. For this we need a puppet. To make the puppet, we need to get a few pieces of colored paper and cut them in the shapes of arms and legs. After that, we need to attach it to the puppet. And then we have to put a stick at the bottom of it. Now the puppet is ready. As you can see, when I rotate the puppet like this, the arms and legs stay away from the central point. This is because of centrifugal force. In centrifugal force, the particles will stay away from the fixed point. Thank you.
Hey there! Today I, Asim Krishna Prasad of class 11 Science from KV Kathmandu is going to demonstrate a simple physics experiment. For this experiment, we are going to need a heavier ball and a lighter ball, both tied to a string with a hollow roll between them. You can see one is heavier and one is lighter. Now, I am going to ask my friend Shubham to please try to lift this heavier ball without changing the vertical position of this roll. Please try it.
Sorry, I can't.
Well, I am going to tell you how we can do it. I am simply going to rotate the lighter ball. You can observe that the heavier ball is lifted up. Why is this happening? There is a simple physics concept behind it. When I rotate this smaller ball, the center of the circular path observed by this ball is here. Now the centrifugal force which acts on this smaller ball is trying to throw it away from the center. When it tries to go away from the center, as the two balls are attached to a string, it lifts the heavier ball. Thank you.
Good morning. I, Medha Upadhyaya of class 6 of Kendriya Vidyalaya Kathmandu stand before you to present an experiment based on Newton's third law of motion. In my experiment, I am using rubber band, thread, matchsticks and empty refills. Here it goes. See, action and reaction. Thank you.
Good morning, I'm Madhav Baheti. And I Akshat Maheshwari. And I Pratmesh Singh of class 5 of Kendriya Vidyalaya Kathmandu are going to show you an experiment on Newton's third law of motion. For this, you will need a pair of scissors, straws, some tape, some string and some balloons. Firstly, blow up a balloon like this, but do not tie the end. Now, stick a straw above the balloon. We have a model to show you. Then, take some string, put it in front of the straw and take it backwards. We have a model to show you the whole experiment. He is going to leave the balloon and the air which will come out is going to be the action and the reaction will be the balloon will move forward. As you can see that the balloon has traveled farther than it was before. Thank you and have a nice day.
Good morning. Today I, Miss Khan of class 7 of Kendriya Vidyalaya stand before you to show an experiment on blooming flowers. For this experiment we require a paper flower, ball and some water. And it goes like this. Let's see what happens. When the water enters the paper flower swells, hence it blooms. Thank you.
Hello everyone, today I am Nikita Birwala of grade 11 science from Kendriya Vidyalaya Kathmandu. I am here to demonstrate an experiment on centrifugal force and the topic of my experiment is sticking water. The materials required for the experiment are a water bottle, a tumbler, water and a rope. First of all, we will upset the water bottle normally, then the water spills out of the bottle. This is because at this condition only one force is acting on the water, that is the gravitational force that pulls it downwards. Now we take a bottle that is tied with a rope and when we rotate the water does not spill out of the water. because the bottle is in a circular motion and the water. At this condition, two forces are acting on the bottle, that is the centrifugal force and the gravitational force. The gravitational force pulls the water downwards and the centrifugal force pushes it outwards. Due to this, both the forces being contrary to each other, the water from the bottle does not spill. Thank you.
Hello everyone, I'm Shalvi from class 12th, Kendriya Vidyalaya Kathmandu, and I'm here to demonstrate an experiment on the topic inertia of a body. For this experiment, all you need is a glass of water and a strip of paper. Now we need the setup. All you need to do is take a plain table and put a strip of paper and put the glass on top of it. Now, pull this paper with a sudden jerk. You will expect that the glass will fall along with the strip of paper, but what happens is actually the converse of it. Now I will show you the experiment. The glass did not even move. This is due to the property called inertia of a body. This is called inertia of mass. When I pull the paper, the glass does not fall because the force applied by me on this glass of water is resisted by the inertia of this body. Also, now I would like to explain to you the significance of this experiment in our daily lives. When a person steps up in a moving bus, he tends to lean backwards. This happens because when he steps up in the moving bus, the feet of that particular person get into motion and his body opposes that particular motion due to the inertia of the body. Thank you.
Hey there, I am Saundarya S. of class 10th from Kendriya Vidyalaya, Kathmandu. I am here before you all to demonstrate a simple physics experiment which deals with Newton's third law. Now let me say the materials required for this experiment. The materials required are 2 pencils, a cloth peg, a matchstick and some thread. Now let us start this activity. Take a cloth peg and try to tie the thread around the cloth peg in such a way that it does not bends or moves away in this way. Place 2 pencils in either sides of this cloth peg. Now try to burn this cloth peg. Wow, this was nice. Everyone knows that the pencils will of course go to an extent, but they may not know that this pencil are of identical size and they move to a same distance and the force applied is also the same. So this is my activity which says that every action has equal and opposite reaction. Thank you.
Hello everyone, I'm June Singh from Kendriya Vidyalaya Kathmandu, currently studying in class 11. The topic of my experiment is shaking without shaking. This experiment revolves around the transfer of heat from our body into this bottle. Now, the material required is this bottle. The setup is quite easy. First, we loosen the cap of the bottle, we turn it upside down, and we place it in such a position that the water goes up to the cap. Then we take it down again and we remove our finger. But there's one thing to be noted while removing the finger, that no air should enter between the gap. The water should stop the air from entering or the experiment will not happen. Now we hold the bottle at the top and after some time we see that the cap of the bottle is shaking automatically. Yes, people, this is not magic, this is science. This is because the air which is present inside this bottle, in this layer, is very cold due to the presence of the water over here. And when I hold it, the warmth of my hand gets transferred inside the bottle, heating up the air. And the air molecules inside this bottle, they all start expanding. And due to expansion, this cap starts moving and vibrating. But since we had already placed it under the control of water, the water does not allow the cap to leave. Therefore, this continues to shake until the heat of our hand and the temperature of our hand and the temperature of the bottle remains the same. Here again I'll show it to you one more time. We remove the finger, making sure that there's no air gap, and then we hold it tight. And it starts vibrating.
Good afternoon. Today I, Karnu, and our program of Class 6 Kendriya Vidyalaya Kathmandu are here to present a science experiment before you. As we know, if we take a piece of cloth and hold it or touch the flames of a lighted candle with it, it will start burning. But today we are here to perform an experiment where even though the piece of cloth will be touching the flames, it will not burn. Firstly, we will light a candle and then place it on the table. Then we will take a coin and place it on the piece of cloth. After it has been placed, we will twist the area around it. After it has been twisted, we will slowly take it near to the fire. As you can see, even though the flames are touching it, it is not catching on fire or burning. This occurs due to the coin. The coin is taking all the heat on its surroundings to it and not letting the piece of cloth burn. As you can see, the piece of cloth has only become black and is not burnt, and the coin is still intact. Thank you.
Today, Samana Pandey of Class 6 from Kendriya Vidyalaya Kathmandu is here to present you an experiment. The title of my experiment is Magic Balloon. To do this experiment, first we need 2 balloons and 1 candle. First, we have to put the balloon in the upper part of the candle. As you can see, the balloon burst. Now I will put another balloon in the upper part of the candle. As you can see, the balloon does not burst. This is because I have put little amount of the water inside the balloon, so the balloon will not burst. Thank you.
Good morning. Today I, Amandeep Singh of class 10th of Kendriya Vidyalaya Kathmandu stand before you to describe you a simple experiment. The materials required for this simple experiment are easily available. The materials are a plastic bottle filled with water which is mixed with black ink, tripod stand, beaker and a monochromatic red light. First we fill the bottle with water which is mixed with black ink, and then we open the hole. Then slowly we aim the monochromatic red light at the hole. Now we press the bottom. The phenomenon taking place is of total internal reflection. It happens only at a particular angle, called critical angle, which I am showing it to you. Thank you.
Good morning. Today I, Ramnath Agarwal of Class 7 from Kendriya Vidyalaya Kathmandu is going to present an experiment on water lens. The materials required are 1 transparent plastic, 1 book and some amount of water. When we place the book in front of the transparent plastic, you can see that the letters magnifies. This happens because the water takes the place of convex lens and it magnifies. Thank you.
Good morning, I am Shakambari of Class 4, Kendriya Vidyalaya, Kathmandu is going to show you an experiment. The things required for this experiment is 2 With one candle, we can see many candles. This is due to multiple reflection. Thank you.
Good morning. Today I, Sachin Agarwal of class 9 of Kendriya Vidyalaya Kathmandu is going to present an experiment before you which is based on light in which I disappear an object. For this I need 2 beakers, one small and one big, and some cooking oil. I place the small beaker inside the bigger beaker in such a way that both the beakers are visible. Now I start pouring some oil in the inner beaker until it is full. Both the beakers are now clearly visible from a distance. I'll continue pouring the oil until the second beaker is filled up to the level of the first beaker. Are both the beakers visible now? No, the smaller beaker has disappeared. Do you know the reason behind it? This is because the refractive index of the oil is higher than that of the refractive index of the material of the beaker. That is why the inner beaker has disappeared. Thank you.
Good morning. I, Shaunak Kulkarni of class 10 of Kendriya Vidyalaya Kathmandu stand before you to describe how the rays of light meet. The materials required for this experiment are easily available. What all you need is a shoebox, a glass filled with water, a torch, a pair of scissors, a pencil and a ruler. But how can you do this? I'll tell you. Firstly, take the shoebox and cut 3 notches in the short side of the shoebox, which should be 1 centimeter apart. Then, place the glass filled with water in the center of the box, which should be in line with the notches. And finally, in the darkened room, switch on the torch and shine it on the notches. You will notice that before meeting the glass, the rays of light are parallel, but after passing through the glass, they meet at a certain point. The point where these rays of light meet, they are stronger. But why does this happen? This happens because the spherical curvature of the glass and water acts as a lens and causes refraction of light, causing them and making them meet together and then cross over. Thank you.
Good morning. Today I, Siddharth Agrawal of class 6 of Kendriya Vidyalaya Kathmandu is here before you with an experiment based on light. Materials required are a battery, 2 connecting wires, a switch, a motor and a circular cardboard colored with 7 colors of rainbow. Here it goes. Oh, it is white. This means
White color is made from 7 colors of a rainbow. Thank you.
Good morning. Today I, Divyam Sharma of class 6 is going to present an experiment on blocking the magnetic field. The things I will require: a paper, a plank of wood, a steel scale, a magnet, pin and thread, a stand and a plastic cup. As you can see, the paperclip flies because there is a magnetic attraction created here. Now I will try to pass a paper. The paperclip does not fall because the magnetic attraction is still there. Now I will pass a steel scale. The magnetic attraction again does not stop. Now I will pass a plank of wood. As you can see, the paperclip falls because the magnetic attraction created here is blocked by the plank of wood. Thank you.
Good morning. I, Srishta of class 7 of Kendra Vidyalaya Kathmandu, stand here to demonstrate an experiment on attraction of magnet. Material required: a glass, some water, some sand, horseshoe magnet and a pin. First, take a pin and put in a glass, and above that put some sand. And take a horseshoe magnet and try to take out the pin from the glass. It will not come. But when you put a pin in a water and you try to take out, it is coming. This happens because the magnet force could be dissolved by the outer wall of the glass. Thank you.
Good morning. Today I am Anpriya Kaur of class 6 is here to present an experiment before you. For this we need a sheet of a paper, 2 magnets and some iron sand. The method for this is take a sheet of paper, place 2 magnets under it, then sprinkle some iron sand on it. As you can see now, some lines has been made. This is because of the magnetic force, lines of force. Thank you.
Good morning. Today, I, Rishabh Koirala of class 8 of Kendra Vidyalaya Kathmandu is present before you to demonstrate a simple experiment concerning elements and compounds. Now, the materials required: iron fillings, bar magnet, petri dish, tripod stand and some sulfur powder. Now, we will take some iron fillings and show with the help of a bar magnet that it is being attracted because it is a magnetic substance. Now, we will take some sulfur powder in a petri dish and add to it a small amount of iron fillings. We'll put it here and let it burn for some time. Now, we can see that the sulfur is starting to burn and starting to release SO2 gas, that is sulfur dioxide. Very soon the iron will get mixed with the sulfur and form a new substance. Now, after letting it burn for some time, we can again test this new substance with a magnet to see whether it is being attracted or not. We have observed that the new substance is not being attracted by the magnet. Why so? This is because iron, one element, and sulfur, another element, upon heating have combined to form a new substance, a compound that is called iron sulfide. And while combining, they too have lost their individual characteristics and developed new one, like they have lost their magnetism and developed something else. This shows that upon heating, some elements can combine into a new substance, a compound, and while losing their characteristics, they acquire new ones. Thank you.
Today, I'm Ashna Shrestha of Class 6 from Kendriya Vidyalaya Kathmandu is going to present an experiment before you. And the name of my experiment is how a metal safety pin floats on water. Now, as you can see, this metal safety pin is sinking on the water. Now, I'm going to put this piece of tissue paper on top of the water and this safety pin on top of the tissue paper and push the tissue paper gently down. Now, as you can see, this metal safety pin is floating on water. It happens because of surface tension in the water, which affects the pin, thus helping it to float on water. Thank you.
Hi, I am Harsh Mohanka of class 10 of Kendriya Vidyalaya Kathmandu. Today I will be showing you an activity where a small amount of water can be used to irrigate a large patch of land. For this experiment, we take 2 cardboard sheets and few water in a glass and a surfactor. Now, to these cardboard sheets, I add a few drops of water. Now, to the second cardboard sheet, I add a drop of surfactor. Now, we can see that in the first cardboard sheet, the water does not spread. Whereas, in the second cardboard sheet, we can see that the water is spreading on this cardboard sheet. Now, this happens because the surface tension is broken. Thank you.
Good morning to one and all. Today, I, Roll Maman Roy of class 9, stand before you to demonstrate an experiment about surface tension. The materials required are easily available. The materials are pepper, bowl of water, and a liquid soap. Now, sprinkle some pepper powder onto the bowl. Now, you will see that the water is covered with the pepper. Now, put one of your finger into the liquid soap. Now, gently touch the middle of the water surface. Now, you will see that the pepper flies happens because the soap breaks the surface tension of the water. Thank you.
Good morning. Today I, Sonali Agrawal of class 11 science from Kendriya Vidyalaya Kathmandu, Nepal is going to show you an experiment based on breaking of surface tension, for which the materials required are milk, orange food color, green food color and maroon food color, liquid soap, plate and some stick. Now I would like to take some amount of milk. And then few drops of food color.
Hey there, today I, Ankesh Krishna Prasad of class 8th KV Kathmandu am here to show you a mathematical experiment. I have a paper with a hole in it and a pair of buttons. This button is slightly bigger than the circle, so it can't pass. But when I fold the paper and again try, this time the button passes. Why is this happening? This is because when we fold the paper, it gives us the shape of ellipse, and the diameter of the ellipse is slightly bigger than the circle from which it is formed. That's why it allows the button to pass through it without tearing the paper. So, it's a simple trick, but lots of science including. Thank you.
Hi, today I, Ankit Maiti of class 11 Science KV Kathmandu is going to demonstrate a simple physics experiment before you. For this we need 6 to 8 glass beakers and a fork. I have aligned these beakers in a straight line just few centimeters away from each other, and I filled these beakers in such a way that the first beaker has the most amount of water and the last beaker has the least amount of colored water. And now, I'll take this fork and strike this on the walls of these beakers to create pitches. Now, when I hit these beakers, we observe that at every different beaker, the created pitch is different. The reason behind this is the varying amount of water present in these beakers. And now, at last, we can strike the beakers in any order to create music we like.
Good afternoon. Today I am Medha Upadhyaya of KV Kathmandu of class 12 science stand before you to present a simple physics experiment regarding how sound travels. For this we need a pack of cards. First of all, we fold this card in this manner and arrange this in this sequence, one after another. While tipping on the first card, whole sequence gets disturbed. In the same way, one molecule hits other and produce vibration. Thus, we are able to hear sound. Thank you.
Good afternoon one and all. Today I Pragya for you from Kendriya Vidyalaya Kathmandu of class 8 stand before you to show an experiment that is invisible ink. For this experiment the materials which are required are a beaker with some water, a candle, a matchstick, a blank sheet of paper, some cotton buds, a spoon and half a lemon. For this experiment, firstly we have to take a beaker and squeeze some lemon juice in this beaker. After squeezing the lemon juice, we will add a few drops of water in it and mix it nicely. After the dilute solution is ready, we will take a cotton bud and dip inside. Now I am ready to write my secret message. Now here's my secret message ready. Now we will keep this message to dry for a little time. Now my sheet is dry. Now see the sheet nicely. Can you see anything in this sheet? Anything written? I think no. See properly. try to identify anything written on this? Okay. Now, lastly, you have not seen anything. Now, I will keep this paper a little near to the flame. Now, see the blank sheet which you have seen earlier. Now, is there any difference? Yes. Now you can see my message. Science is fun. Now I stop my experiment. Now